So our last section for this week is going to be on finding two different formulas. Okay, one's going to be called arc length. The other one is an area formula. And we're going to figure out where they come from, and we're going to do a lot of this work in radians. So keep in mind, anytime they give us something that's in degrees, we're going to have to do what we learned yesterday, okay, convert things to radians. All right, so let's start out with this picture. Okay, so what I've drawn is a circle. Inside the circle, I've drawn two angles. And I've labeled the names of these angles using two Greek letters. Does anybody know what Greek letters those are? Yep.
Theta.
Yep, theta. So I've called this angle theta, and I called this other angle just something different, theta 1. And each angle has an arc that corresponds to it. If you look at angle theta, the sides or the rays come out, hit the circumference right there of that circle, and I have an arc between those 2 points. Okay, I've called that arc S. Okay, that's the letter S. Theta 1 is a different angle. The rays come out, and they hit the circumference of the circle right there, and I have another arc, and I'm calling that one S1. All right, so what we need to figure out here is a formula to find the length of an arc. Okay, and I'm going to go back to something I did yesterday. I talked a little bit about conversions. Okay, we talked about how to, if we can find a connection between two things. I think I gave the example of in one revolution there was 360 degrees. And using that, I can set up a proportion. And I can find any number of degrees that I want. You tell me you've got 3.4 revolutions. I can tell you how many degrees are in that amount of revolutions. Okay. Same thing if I said to you in 1 foot, okay, there's 12 inches. You can use this fact to convert any number of feet to any number of inches. Okay, you just need to know that one fact. So if you said to me, well, I have 96 inches. How many feet is that? All I have to do is write down how many inches you gave me. I don't know how many feet it is. And then I cross multiply, and I could solve it. Now, because I use the number 1 and the number 12, does this conversion limit what numbers I could put on the right-hand side? Connor?
I don't think so.
No. I can put any numbers I want here. Just because I picked a 1 and a 12, that's just the simplest conversion I could think of between feet and inches. I could do this if I want. This is another conversion that would work perfectly well to convert feet to inches. It's just not as simple. Okay, so the numbers that you pick for your conversion don't affect the numbers that are on that right-hand side. Okay, I can still convert anything to anything. I just need a fact to start with. And that's what I'm going to figure out. I need a fact to start with here. And that'll let me do anything I need to do. So, we're going to start off by letting theta 1 equal something. And just because I'm about to let it equal a certain number, it's not going to limit what I can do with it. Still going to be able to convert anything to anything. But does anybody know what I could let theta 1 equal? And if I let it equal this number, I'll automatically know the size of this arc based on something we did yesterday. If this theta 1 is a special number, the size of this arc will automatically be the same as something else. And that's going to be our starting point. Yeah. Okay, what we did yesterday. This just happens to be a relationship that's always true. If you let your angle be 1 radian, it automatically makes this arc the same size as the radius. Okay? And that's our starting point. Okay, we're going to use that fact. So if theta 1 equals 1 radian, then that automatically would make S1 exactly the same size as the radius. Any questions on that step? Okay, so that's my first step. I want that equal 1 radian, and if that's 1 radian, then that arc is the same size as the radius. All right, so next thing I have to explain is what's called proportional. Okay, the size of the arc and the size of the angle are directly proportional. What that means is if you double the size of this angle, you double the size of this arc. If you make that angle half as big, you make the arc half as big. Okay, so that size of the angle and the size of the arc are directly proportional, which means we can set up a proportion. Okay, and there's a lot of different ways you can set up this proportion. I'm going to compare an angle on top to an arc on the bottom. I'm going to do that on the left, and then I'm going to do it on the right. So I'm going to compare, let's say, theta 1, that angle, to its arc, and I'm going to compare theta, that angle, to its arc. Okay, and the reason I can do this is because angle size and arc size are directly proportional, so you can set up a proportion. That angle compared to that arc equals that angle compared to that arc. Now, two of those things I'm going to fill in for. What did I say I was going to let theta 1 be? Yep, I'm going to let that be a 1. So I'm going to fill in for that. And what did I say I was going to let S1 be? That's going to be R. Now, the other side, I don't know anything. I'm just going to leave it just like that. So now I have 1 over R equals theta over S. And my last step is to do out this proportion. And does anybody know the name of that thing you use with proportions to solve them? Yeah? Yeah, we're going to cross multiply. We're going to do S times 1, which is just S. And then we're going to do R times theta. There's not really much I can do with R times theta. I just leave it. And that is your arc length formula. S equals R theta. Okay, so that whole formula is based on that facts that we said yesterday. You have to know that, and you have to understand that angle size and arc size are directly proportional. Okay, so that is your arc length. R is your radius, and theta is your angle. But we have to be careful with the angle. Way back at the beginning, what did I suppose? I said that theta 1 was equal to what? 1 what? 1 radian. Okay? So this formula is based on the assumption you're using radians. Okay? So if you try to use this formula and you have something in degrees, it doesn't work. Okay? So S equals R theta. There's your formula. And there's really 3 different types of problems you could have. I'll always give you 2 out of 3 of these variables, and you're going to find the third one. Okay? So we'll go through one of each. Okay, so the first one, I've kind of written the whole thing out. A lot of times what I'll do instead of writing it is I'll just draw a picture. But for this one, I wrote it out. All right, so we've got a circle, and we have an angle that we've drawn inside that circle of pi over 3 radians. And they tell me the radius is 4 inches. Find the length of the arc. All right, so if you're somebody who's more visual and you want to see a picture of what we're actually doing, okay, here's our circle. Here's an angle of pi over 3 radians. We've got a radius of 4 inches. Find the length of this arc. That's what I want to know. Guys, the first thing I did is I just wrote down the formula we're going to use, S equals R theta. And Skylar, can you tell me, in this problem, they give us 2 numbers. Can you tell me what either one of those numbers, what letter it represents in that formula?
Not sure.
Not sure?
No.
You got this. Look at the third line in that problem. It tells you something about the 4 inches. What's in front of it?
Formula radius or radian?
R. R is your radius.
All right, so the radius is 4 inches.
Yeah, radius is 4 inches. Good. Right, so I'm going to fill that in for R. And Sam, how about pi over 3? What's the pi over 3? Yeah, I have an angle of pi over 3. So I'm going to fill in pi over 3 for my angle, fill in 4 for my radius. Okay, and for this one, there's not really a lot to do. Just multiply it together, and you get 4 pi over 3. That's my arc length. Now, since it's a length, what's the unit in this problem they use for length? Inches. So the length of that arc in red is 4 pi over 3 inches. Okay, if you're saying, well, how long is that really? Well, you could do it out. 4 pi divided by 3. It's about 4.2 inches. Okay, if they ask for a decimal. Or 4.189. Most of the time, they're not going to ask for a decimal. You could just leave it 4 pi over 3 inches. Any questions on how we found the arc length there? All right, so let's try this one. Okay, this time, rather than writing it all out as a description, I just draw a picture. So I've got an angle that's 130. I have a radius of 8 feet. Find the length of that arc in red. Katrina, can you remind me, what's the formula that I use again when I'm looking for length of an arc? Yep, S equals R theta. And Rebecca, what's one number here that I could plug in, and tell me what letter you plug it in for?
8 feet for the radius.
Yep, I like that. So we have 8 feet for the radius. And Nolan, what about the 130? What's that? Okay, 130, that's definitely an angle. Does anybody have any thoughts on that number? Something I said to be careful with. John?
You have to convert to radians.
Right. Okay, remember this formula only works when theta is in radians. Okay, so this time we got to convert it. I'm just going to do that off to the side. John, can you remind me how I convert that? pi over 180. If I want, I can divide top and bottom by 10. So that's 13 pi over 18 radians. Okay, don't even worry what it is as a decimal. We don't need it. Okay, if I want, I can reduce this a little bit. What number goes into both 8 and 18? 2. Yeah, so we can divide by 2. And I get 4 times 13, which is how much? Yeah, 52 times pi divided by 9. Okay, and what does that number represent? Is that an arc length? Is that an angle? Or is that a radius? Okay, it's equal to S, so that's an arc length. So what should be my unit on length this time? Feet. Okay. Any questions on that one? Very similar to the first one. The only extra step, you've got to convert degrees to radians. All right. Okay, example 3. Suppose we have an arc length of pi over 4 centimeters and a radius of 12. Find the angle. Okay, so this time they switched it up a little bit. They're giving me different information. Okay, Brian, can you tell me that pi over 4, what letter is that?
That'd be S.
Yeah. Suppose we have an arc length of pi over 4. That's my S. So that goes in for S. And Jake, what about the 12?
12 is the radius, so it goes in for R.
Yep, that's my radius. So plug that in for R. And we're going to find the angle. Okay, so let's fill it in. Okay, pi over 4 equals 12 times theta. And now we're just going to get the 12 on the other side. Okay, so Shakira, how do I get that 12 on the other side?
Could you divide it by 12?
Yeah, divide by 12, which is exactly the same as just multiplying by 1/12. Okay, so I'm just going to throw the 12 in the denominator. 12s cancel out. And I get an angle of pi over 48. Okay, that's an angle. Okay, that's equal to theta. That's not an arc. That's not a radius. So that's not a length. So what should be my unit on my angle? So think about in this formula, what did we say angles are always measured in? Yeah, always measured in radians. Okay, angles are always in radians. Okay, wouldn't make sense to have centimeters because you don't measure an angle in centimeters. You measure an angle in degrees or radians. That's it. So should I put RAD? No. Okay, I don't need to. Yes?
Why did you divide by 12?
So think of it like if you had an equation like this. 3 equals 12x. Since this is multiplication, 12 times x. The only way to get the 12 on the other side is to divide. Okay, so you always do that opposite operation. If you want to move something to the other side and it's addition, you subtract it. If it's multiplication, you divide it. Okay, any questions on that? All right, let's try Try one more. This time it says find the radius. Okay, so take a couple minutes to try that one on your own. Okay, see if you can figure out the radius. Okay, what's the first thing you have to do in this one? Eric?
You have to convert the 36 degrees to equal.
Yeah, okay, they give us an angle that says 36 degrees. Okay, first thing we want to do is change that to radians. So I'm just going to do that off to the side. So I'm going to multiply by pi, divide by 180. 36 might look like kind of a messy number, but it does come out nice. How many times does 36 go into 180? Yeah, it goes in exactly 5 times. Pi over 5 is my angle. Okay, my arc is 13. So S equals, just leave R right where it is, we don't know it, times my angle, pi over 5. Now my last step is I want to get the pi and the 5 both on the other side. So I can do it in 2 steps or I can do it in 1. Does anybody know what I could multiply both sides by? Yeah, multiply by the reciprocal. And it'll move that whole thing in 1 step. Okay, if you said, well, can I divide by pi over 5? Yes, that's the same thing as multiplying by the reciprocal. So I'm going to multiply by 5 over pi. It's going to cancel the 5s and cancel the pi's. And do the same thing here. Multiply by 5. I don't want that to look like 5.15. And divide by pi. Okay, simplify that, and then that's our answer. What's 5 times 13?
65.
Yep. 65 divided by pi. And what was that? Is that an arc length, an angle, or a radius? It's a radius. Radius is a length. What were lengths measured in this problem? Feet. Okay, and for those of you that did it as a decimal, you would get 65 divided by pi. It's about 20.69 feet.
Do we have to put in decimal form or can we just keep it?
This problem, it didn't say, so you could leave it exact. Okay, on the test, it'll always say in the directions. Either leave it exact or write it as a decimal. Okay, so any questions on that? It's pretty much every type of problem you could have with arc length. Okay, solving for each thing. All right, last formula we're going to look at is area of a sector. Okay, and I'm going to start out with a diagram again. It's pretty much the same diagram I had last time, except I'm not focusing on arcs. I'm going to focus on areas. So what I've done here is I've drawn a circle again. Inside the circle, I've put 2 angles. Same angles I used last time. Theta and theta 1. And I've also labeled the areas that those 2 angles create. Okay? This is the area for A. And down here, that's the area A1. Okay? Those 2 shapes that I just shaded, those are called sectors. Okay? So basically a sector, it's like a piece of pizza. Right? It's got 2 straight sides, and then the top side is an arc. Okay, so they're not quite triangles because they have that curved side. Right, and the goal here, it's the same goal we had last time. We have to have a starting point. Okay, we have to have that in 1 foot, there's 12 inches. If we don't have that starting point, we can't set up a proportion, we can't figure out anything else. All right, so we're going to do what we did before. We're going to let theta 1 equal something, but this time we can't let it equal 1 radian. We're going to have to let it equal something else. Okay, before I give you a hint, does anybody have a guess what we can let theta 1 equal? All right, let me give you a hint. Let's start with this picture. What's the angle there in that picture? Okay, so that's a 90-degree angle. And how much of the circle is filled in? How much of the circle does a 90-degree angle kind of block off? Yeah, a fourth of it, or a quarter of it. Okay, so if I go, let's go a little bigger. Okay, I have a straight angle now. And how much of the circle does 180 degrees block off? Yeah, it's half of it. Okay.
Wouldn't we put the two areas together? You know what? Just a thought, like to find the area of all of it.
Okay, so yeah, let's jump to that idea. Let's think about finding the area of all of it. What angle would I have to have here that would take up all of it? Right, 360. Or in radians, it would be how much? 2 pi. So if we pick an angle that's so big it takes up the entire circle, we should already know how to find the area of this. Okay? This shape isn't even a sector. It's a sector that's the entire thing. We just call it a circle. So if we can figure out the formula for the area of a circle, we know that this angle takes up the whole thing. We'll have a connection between the size of an angle and the area. Okay, we just need to know what is the formula for the area that takes up the whole thing. We already know the angle that takes up the whole thing. What's the formula for the area of the whole thing? What is it?
Pi r squared.
Pi r squared. So if we let theta 1 equal 2 pi, then that sector becomes so big it takes up the whole thing. And the area automatically becomes the area of the entire circle. Pi r squared. Okay, so here's going to be our starting point to figure out the formula for the area of a sector. If theta 1 equals 2 pi, then the area is pi r squared. Okay, that's like saying in 1 foot there's 12 inches. This is the fact we're going to start with that lets us figure out other things. If you didn't know that 2 pi is the angle that takes up a whole circle, and you didn't know pi r squared is the area of a circle, we would be stuck. Okay, so you have to know that formula. Okay, and the other thing we can use again, which is the same as last time, is the size of the angle and the size of the area are directly proportional. Okay? Make this angle twice as big, you make the area twice as big. Make the angle half as big, you make the area half as big. Okay, so now let's set up that proportion. Okay, based on what we did the first time, anybody have a thought what I can set up for my proportion? What compared to what equals what compared to what? Using these 4 things in the picture. A1, theta, and theta 1. Bless you. And there's many ways to do it. As long as you, whatever you do on the left, you do the same thing on the right. Yeah.
A over theta,
Big area to big angle. Sure. Yep.
and then A1 over theta 1.
Perfect. So area to angle, area to angle. And now we're going to fill in 2 things we know. Let theta 1 equal 2 pi. Let area 1 equal pi r squared. And on the other side, we don't have anything to fill in. Just leave it as A over theta. Okay, what was the technique we used last time to solve proportion? Yeah, we're going to cross multiply. But before we even do that, does anybody see something I can cancel out here? Yeah, you have pi in the top, pi in the bottom. So you can cancel that out. Now I'll cross multiply with what's left. A times 2, or we normally write 2a, equals theta times r squared. Or r squared times theta, same thing. Oops. Okay, so I got 2 times a equals theta r squared theta. Now the only problem is I don't want a formula for double the area. I want a formula for just area. A equals. So how would I get A by itself? Yep.
Divided by 2.
Yep, divide by 2. Would you say multiplying by a half is the same thing?
Yes.
Yeah, so I'm going to do it that way only because that's how the book does it, but it's exactly the same thing. Multiply by a half. Multiply by a half. Those cancel out. And there is your formula for the area of a sector. Okay, in each letter, what they stand for. A is your area. What do you think R is?
Radius.
Yep, R is your radius. And what about theta? That's your angle. And just like we did last time, look at what we assumed way back at the beginning. What is 2 pi? We assumed that that was our angle. 2 pi what?
Radius.
Radians. Okay, so way back at the beginning, I didn't use 360 in the formula. I used 2 pi. Okay, so same deal as last time. You got to have radians. Okay, so A equals 1/2 r squared theta. Okay, just like arc length, you'll always be given 2 out of 3 things, and I'll have you find the third. Okay, so we'll go through one of each. We'll ask you to find one of each thing. Okay, so first one asks you to find the area of that sector. Does everybody have the formula on the left so I can make what's on the right a little bigger? Okay.
Is that pi over 6?
Yes, pi over 6. All right, so now first thing I got to do is figure out what formula do I need for this problem? Because now we've got 2. Is this an arc length problem or an area problem? Find the area. Okay, so we're going to find the area of the sector. Okay, so first thing I like to do is just write down the formula. What's that formula for area again?
1/2.
Theta. Good. Okay, now I'm going to look at what they give me. I'm going to plug it in the right spot. Find the area. Okay, I don't know A. Do I know the radius?
Yeah.
Yep, radius is 4. And do I know theta?
Yeah.
What is it?
5
Pi over 6. Do I need to convert it? Nope, it already is in radians, so it's ready to go. Okay, let's do this part out. What's 4 squared?
16.
And then half of that? So I have 8 times pi over 6. And my last step, just like we do, reduce if there's anything you can reduce. What is 8 pi over 6 reduced to? Yep, 4/3 pi. Or 4 pi over 3. Now that's equal to A. Is that an area, is that a radius, or an angle? A stands for area. So how should I label my area? What unit should I use? Centimeters squared. Right. Okay, remember, area is two-dimensional, so it should be square centimeters. Okay, and like we did before, if you want to know what is that, okay, how many centimeters is it? It's 4 pi divided by 3. It's about 4.19 square centimeters. Okay, so any question on finding that area? All right, so that's the first one. Okay, second one, find the radius. And this is going to tie in some of the stuff we learned about square roots. Okay, you'll see how in a minute. Okay, based on what they've given me in this problem, should I be using my formula for area or arc length? Area. How do you know it's about area? Yeah, it's got a number right here that is an area. Inches squared is area. Okay, so I'm going to start with my formula. 1/2 r squared theta. And before I even plug in, I'm going to check to make sure the numbers that I have are ready to plug in. Sam, do you think that both of these numbers are ready to go the way they are, or is there anything I need to do first? Yeah, I do have to convert degrees to radians. Okay, if you go through all the steps to do it I taught you yesterday, you'll get pi over 4. All right, now I'm ready to plug in. So my area is 8 pi over 3. I got 1/2. I don't know the radius, so just leave it. And theta is pi over 4. Okay, so my goal is to get this r by itself. Or even a little simpler goal to start out with, just get r squared by itself. Okay, so get all these numbers on the other side. Let's start with the pi over 4. How could I get the pi and the 4 on the other side both at the same time? Yeah, multiply by the reciprocal. That's going to cancel the 4s. That's going to cancel the pi's. Anything else that's going to cancel out now? Yeah. You got pi in the top, pi in the bottom. Now on the left-hand side, let's just multiply it out. 4 times 8. 32 over 3 equals, I still have 1/2 r squared on the other side. Okay, next step, I would try to get that 1/2 on the other side. Okay, how do I do that? Jared? Yeah, it's really the same step we just did again. Multiply by the reciprocal. It's going to cancel the 2's. Multiply by 2 over 1 on the other side. So now the 1/2 is gone. You're left with r squared on the right. Okay, and then on the left, 2 times 32 gives me 64 over 3. Okay, now it says r squared equals. Eventually, I just want r. So what do I do now? Yep, square root. And when you take the square root of a fraction, the way you do it is you just do the top and the bottom separate. So take the square root of each side. Now we finally have r by itself. And some of this I can simplify a little bit.
Square root of 64 is 8.
Yeah, the square root of 64 is 8 over the square root of 3. And that's a radius. A radius is a length. Lengths in this problem, inches. Okay, any thoughts on that? We talked a little about this yesterday. Yeah? Right. Hey, as far as trig goes, we're done the trig. Now we're just playing with numbers here using arithmetic to write it nicely. And how do you get that square root out of the bottom? What you have to do? Multiply the top by anything else? And the bottom. Okay, so all this is going to do is fix it so the root's not in the bottom anymore, and then we're done. So we get 8 square roots of 3 over the square root of 9, which is just 3. That's my radius. Okay, so the radius one, that one usually turns out to be the longest because of the square root. Sometimes you don't end up with the square root in the bottom. It could come out nice. Sometimes the top comes out nice. This time it was the top. Okay. Any question on the radius? Finding that one? No? All right, so the last one, this one's actually a lot easier. Find the angle. Okay, what's nice about this is they give you the radius, so you're not going to have to worry about doing any kind of square roots. You're going to be able to just get a number squared for your radius. Okay, so take a couple minutes and see if you can find the angle here. All right, so let's take a look at finding our angle. Okay, how about Kyle? Can you remind me, what's my formula again here that has area in it? Yep, 1/2 r squared theta. This time I'm going to fill in pi over 2 for area. I'm also going to fill in for my radius, which is 3. Square it. And I'm going to leave theta because I don't know what it is. John, what's 3 squared? And then 1/2 of 9, how would I write that as a fraction? Yeah, I would just leave it as 9 over 2. Okay, and the reason I left it as 9 over 2, because now in one step, without even dealing with decimals, I can put 9 over 2 on the other side. And I'm going to cancel something at the same time. Okay, how do we move 9 over 2 to the other side? Yeah, just multiply each side by the reciprocal. And what's the reciprocal, Katrina? Yep. Multiply by 2 over 9. Multiply by 2 over 9. 9s are gone. 2s are gone. And the 2s are gone. Okay, so what do I get for an angle? Pi over 9. Okay, questions on that? All right, so let's say I gave you choices of this on a test. 2/9, pi over 9 degrees, or 20 degrees. Which one of those is correct? Or, if you're not sure, tell me which one you know is definitely not correct. Connor?
B is correct.
B is correct?
Well,
Yeah, E is correct.
So the vote for C might be correct.
I know A is not because,
Yeah, A is wrong.
And it can't be B because there's a degree assigned with the radius.
Right. Okay, remember, the answer that you get when you use this formula is always in radians. Okay? A is in radians, but 2/9 really has nothing to do with the final answer, so that's wrong. That's degrees. Okay? So we got to be careful. That's pi over 9 radians. That's pi over 9 degrees. Our answer is not pi over 9 degrees. So the only one that could make sense would be C. And if you do convert pi over 9 to degrees, you do it off to the side. Multiply by 180, divide by pi. 180 divided by 9 does come out to 20. Okay, so if you see something like that on the test, don't get confused and you're like, my answer is not listed. I did everything right. Okay, I've had people check this kind of problem like 6 times. And it's only because they gave you an answer that was multiple choice in degrees, and you have it in radians, which is how you're supposed to do it. All right, so on the homework tonight, they're going to give you a couple different problems. Okay, one of them is going to be about a clock. And it's going to ask you a problem like, I have a minute hand that's 5 inches long. And it's going to ask, how far does the tip of the minute hand move between 12 and 3? What's it really asking for? What kind of problem is that? That's an arc length problem. How far does the tip of the minute hand move? That's an arc length. And the length of the minute hand is really like your what? That's your R, right? That's your radius of that circle. Okay, so they're going to give you a problem with that. And then they're going to give you a problem with a pendulum. Okay, so something swinging back and forth. They're going to tell you that the pendulum swings, I don't know, like an angle of 30 degrees. Find out how far back and forth the pendulum moves. What kind of problem is that? That's another arc length problem. Okay? As long as they tell you how long the pendulum is, and they tell you the angle that it's swinging, you can figure out the arc that the pendulum is tracing. Right? So they'll give you one like that too. Right? But it's all arc length and area problems. Okay, I think there's like three word problems. Okay, so the homework, same page as last night, page 99. Okay, so 71 to 87, just the odds, and 91 to 94, all. Okay, don't forget, tomorrow we have a test on sections 1.1 and 2.1. Okay, I will not be after school today because of the back to school night. And if you sign up before the test tomorrow, I'll give you 5 extra points for going on the website.